Here's a little bit more information about the construction and design of the balloon part of the prop. The balloon was definitely the star of the show, so to speak. It was the main element of the prop, and in fact it was the most time-consuming to construct. I found a template online for a small stuffed toy, and I just enlarged and adapted that for use as the inflatable balloon. I also made a small paper model based on that template just to check to make sure it was the right shape. It seemed to be the right shape, so I went ahead with the design based on that template. However, I did not notice that the very tip of the template was not actually the exact right shape, because the angle did not add up to 360, and that ended up leaving a hole in the top of the balloon. I thought that was actually okay to leave the top open like that, but it turns out that the balloon would not inflate fully when that big hole was in the center top. So I ended up having to splice in a clear round piece in the center of the balloon. But anyway, based on the template, I created a full-size template. I glued some pieces of cardboard together and drew a grid on there, and then I used some flexible acrylic strip to create kind of a spline to try to match the smooth curves in the paper template. And that seemed to work pretty well. So that allowed me to trace it onto the cardboard. And once it was traced onto the cardboard, then I actually cut out the pattern. So this gave me, I actually cut it out in two pieces, the upper and the lower portion, because the overall size of this template was about 12 feet in height. And that was for one single gore. The original paper template that I based this on had 8 gores, and that created somewhat flat surfaces on the balloon shape, which I wasn't completely happy with. So what I did was horizontally divide that pattern in two. So I made twice as many narrower gores, and that smoothed out, or that rounded out the shape of the balloon quite a bit, I think. It looked nicer on the final balloon, even though it would be more work, like more cutting and more taping. So when it came time to actually construct the balloon, I went back to the graphic that was provided from the VBS team at church, and I looked at the pattern they used, and I tried to generalize and simplify that for use on the actual balloon. So I ended up with the central squares, like on the widest part of the balloon, approximating what was shown in the graphic, and then I scaled everything else to match according to that. The only materials used for the inflatable balloon were those cheap plastic tablecloths from Party City and some 3M heavy-duty packaging tape. I used about 1.5 tablecloths of each color. There were 4 pastel colors and 2 tablecloths of white, and these are about 4.5 feet by 9 feet. So there's a substantial surface area on the balloon. And I also completely used a 3-pack of the 3M packing tape. So that's 55 yards per roll, so like 165 yards of tape, which is quite a bit actually. So based on the pattern of the graphic, I figured out how many panels of each color were needed, and so I used the cardboard template to cut those shapes. So I ended up with a big stack of colored panels. When it came time to actually assemble them, I assembled one gore at a time. So basically from top to bottom, I would tape the panels into a vertical column. And so I made 16 of those. 8 of them followed the pattern from the VBS graphic, but I wasn't entirely sure how that was going to end up looking. So on the back half of the balloon, what I did was just make a regular pattern that looked like other hot air balloons, just kind of a wavy pattern with colors. Anyway, that information gave me counts of how many panels of each color to make. So during fabrication, I made 8 gores using the official VBS pattern, and then 8 more gores using my alternate pattern. After taping each gore together separately, then one at a time, I set the gores beside each other and taped them together along the vertical seam. This was actually kind of challenging because there's a curved edge there. In hindsight, I probably should have just used straight edges on all of the panels so that I'd be using triangles or polygons instead of slightly curved shapes. That would have made the taping a lot easier, because on the sections where there was the most curve, I had to tape short sections separately and then join them together. So it would require taping a small length and then kind of bending or holding the plastic sheet at a different angle to tape the next section, etc., and then just go all the way down the seam. I was also a little bit careless during fabrication in that some of the pieces of tape did not overlap sufficiently. Later I discovered I probably should have overlapped them by at least about an inch so that where the joint was would not tear apart, because I actually had a few joints tear apart because the tape did not overlap enough. It created a weak spot. So having joined the gores together, I did one at a time and ended up with a rolled up balloon with 16 gores. Then I had to kind of unroll it and backwards and join the first to the last gore. That one was also a little bit tedious just because all of the other material was in the way. Prior to that, the gores were able to be rolled up and kind of kept out of the way. For the curved and angled sections, I did finally discover an easier way to do that, and that is I would bend the plastic sheet upwards so it kind of formed a corner, and then that would allow the section that I wanted to tape to be pretty much adjacent. And this photo probably doesn't show it too well, but on the left there, the plastic is sticking up because there's a change of angle there, and then flat on the bottom is where I'm taping the new section. I was also a little bit sloppy in either cutting the panels or taping them, and I ended up with a slight gap between some of the panels. Now, cosmetically, it's not a big deal because from a distance you wouldn't see it. However, because this is single-sided tape, it created a sticky surface where the gap is on the underside. And with the balloon either folded or bunched up, that would cause a sticking point. And this tape is actually pretty sticky. If pressure were applied to where that gap is, it would stick onto the other surface, and then pulling it apart too quickly could damage the balloon. So what I ended up doing was putting a thin strip of tape on the back side where those gaps are, so that there would not be a sticky portion exposed to the inside of the balloon. There again, in hindsight, if I had just used straight edges and straight pieces of tape, I probably could have reduced that significantly. And with all the cutting, especially of the shapes of the custom VBS pattern, the living room was kind of a disaster afterwards. Quite a mess. But anyway, I was able to clean that up, and then I set the balloon out on the floor and prepared for a test inflate. I got the blower, set it near the bottom end. Initially, I also put a hem on the bottom of the balloon, just one piece of tape folded over so it would cover both sides of the bottom edge of the balloon. So I did a trial inflate just with the bottom open and the blower, and it seemed to blow up reasonably well. This is when I discovered that the open top and the open bottom were too big to allow it to actually inflate. So then later I decided to close off the bottom and the top. On the top I added clear circular cover in the center, and on the bottom I actually added one layer of panels and then a circular bottom to that, which would completely close off the balloon. Unfortunately, I discovered that the blower was too strong for this flimsy material, and it actually blew a bunch of holes into the balloon. I guess that was a positive sign that the balloon would actually hold air well, but it also highlighted the weakness of the tablecloths. And this picture here actually shows where some of the tape did not overlap by at least an inch. You can see where some of the places where it came together, it just sort of ripped open the tablecloth. Fortunately, the balloon is easy to patch. You just slap another piece of tape over it to hold it together. And I also decided that since it would pop, I cut an outlet vent into it and then attached some plastic edges onto the edges of the vent so that I could clamp them closed when needed or leave them open. Because I didn't want to be turning the blower on and off constantly during the day. I wanted to leave it on all the time. Opening the vent would allow me to leave the blower on all the time and relieve the pressure so that the balloon would not pop. I also added some craft foam little fire spikes onto the blower to try to make it look more like a hot air burner. After doing all that, the balloon inflated quite well, and it was the right shape and it was stable. If I leave the blower on and the vent open, then it would remain inflated, but it would not pop. So that was a major milestone to get to that point, because the balloon really is kind of the highlight of the prop. It finishes off the prop quite nicely from a visual perspective. During setup, I discovered that the addition of pull tabs would have been very helpful as well. So the best time to have done that would have been during fabrication of the balloon. Attaching the retaining ropes over the top part of the balloon would probably also have been easier to do at the time that the balloon was fabricated. That's about all the notes I had on the actual balloon fabrication. It was a very time-consuming and tedious process. I probably spent more time on this than the entire rest of the prop put together. I think it was like a solid 2 or 3 days to cut and assemble the panels on the balloon. But the end result, I think, was worth it. I mean, it really did look pretty good. And it also gave me some techniques to fall back on in future. Now I think I have a pretty solid feel for how to do a custom inflatable shape, both in terms of the finer design details as well as the overall process. So this was definitely a learning experience and beneficial, probably, hopefully, for future props.